Hey kiddos! Today we're actually going to continue with some more in-depth knowledge on conditional statements. We've already talked about the first few different types. We've talked about the hypothesis, we've talked about the conclusion, we've talked about negation, how to write a conditional, the converse. So now we're looking at a few different ones. The first one we're going to talk about is the inverse. So to write an inverse of a conditional statement, you basically just negate both the hypothesis and the conclusion. So if not P, then not Q. And symbols, not P implies not Q. Okay, so that's what inverse means. You make them both negative, or you negate both. The next one is the contrapositive. To write the contrapositive, you first write the converse, then you negate both hypothesis and conclusion. Okay, so to write the contrapositive, you basically you switch the order, which is what the converse is. Okay, converse is when you switch the order of the hypothesis and the conclusion. So you do that, and then you negate both of them. Okay, so if not Q, then not P. Not Q implies not P. So that's what contrapositive is. We have equivalent statements. So just something for you guys to know. When two statements are both true or both false, they're called equivalent statements. The conditional and contrapositive are either both true or both false. The converse and inverse are either both true or both false. Okay, so something for you guys to keep in mind. A biconditional statement is when we have if and only if. Okay, so it's a little different from your conditional statements. Remember, conditional statements are if and then. So a biconditional statement states if and only if. So when a conditional statement and its converse are both true, you can write them as a single biconditional statement. So P, if and only if, Q. Or shorthand IFF for if and only if. Okay. Any definition can be written as a biconditional statement. Okay. So let's go ahead and dive right in. All right. So writing related conditional statements. Write the inverse, contrapositive, and biconditional if one exists. Then decide whether each statement is true or false. So A. Let P be you are a guitar player. Let Q be you are a musician. So remember the inverse, we negate the hypothesis and the conclusion. So that's what we're going to look at first. So we would get if you are not a guitar player, then you are not a musician. That is the inverse. And is this statement true or false? Hopefully you're saying false. That statement is false. Now for the contrapositive, okay, remember we have to switch the order of the hypothesis and the conclusion and negate both. So then the contrapositive for this is going to be if you are not a musician, then you are not a guitar player. Is that true or false? Is that statement true or false? What do you think the truth value is? Hopefully you're saying that's true. So now to think about biconditional. First thing you have to ask yourself is, can you write one? Does it exist? Okay. And remember, for that to happen, we have to have the converse or the inverse need to be true. So let's see. There is actually no biconditional because the converse and the inverse are both false statements. We actually did the same type of example in our last notes when we found the converse of it. Okay, so that's how we knew that. All right. Example B. Let P be the stars are visible and let Q be it is night. Again, this is also should seem already familiar because this is an example from the last notes. So when we get to the biconditional part, you might want to look back at those notes to see what the truth value was for the converse of this. Okay, well, let's go ahead and find the inverse. All right, and the inverse statement would be, if the stars are not visible, then it is not night. True or false? It is false. Now for the contrapositive. Remember, you're doing two things for contrapositive. I like to kind of think of it like that way. It kind of seems like contra, positive, two different words put together. So therefore, there's two actions that are going on when I do this, okay? I switch the order and I negate both, okay? Hope that kind of helps you remember it. So we get, if it is not night, then the stars are not visible. True or false statement? If it is not night, then the stars are not visible. Well, hopefully, golly, you're saying it's true. Now, again, remember, biconditional, look back at your converse if you need to. We already can see that the inverse is false. So if the converse is false, then we kind of already know what our answer is going to be. And it is, no biconditional can be written because the converse and the inverse are both false. All right, rewrite the definition of the term as a biconditional statement. Now remember, biconditional statement means that we have the if, okay, IFF, if and only if. Okay, so A, if two angles are complementary, then the sum of the measures of the angles is 90 degrees. So we're going to write that as a biconditional statement. So it would state, two angles are complementary if and only if the sum of their measures is 90 degrees. All right, B, if two line segments have the same length, then they are congruent segments. The biconditional would be, two line segments have the same length if and only if they are congruent statements. Now, before we go into the answer for C, how about you pause the video, write it down yourself, and check yourself. Nice way to see or practice right now if you can actually write a biconditional statement on your own. So, C, pause. If two lines intersect to form a right angle, then they are perpendicular lines. And the answer is, two lines intersect to form a right angle if and only if they are perpendicular lines. So hopefully you checked it and you got it right. All right, rewrite the statements as a single biconditional statement, okay? So notice you're given two conditional statements and they're asking you to write it as a biconditional statement. So A, if a polygon has 6 sides, then it is a hexagon. If a polygon is a hexagon, then it has 6 sides. So the biconditional statement, obviously, hopefully you remember it's going to have if and only if, would be, a polygon has 6 sides if and only if it is a hexagon. All right, let's look at B. If an angle is a straight angle, then it measures 180 degrees. If it measures 180 degrees, then it is a straight angle. Notice the reason, hopefully you guys caught on that the first statement is our conditional statement. The second one is the converse of it, because the conditional statement is true and the converse statement is also true. And therefore, that is the reason why we actually can write the biconditional. Some of you may have had that question in mind. So that's the reason why we can justify writing biconditional statements for these, because the conditional statement is true and the converse is true. So for this one, you would end up with, an angle is a straight angle if and only if it measures 180 degrees. And C. Again, why not? Pause the video, try it yourself first, and then continue playing the video to see if you got it right. Okay, so check yourself. C. If the polygon has all congruent angles and sides, then it is a regular polygon. If it is a regular polygon, then it has all congruent angles and sides. Make sure you paused it. the answer reveal a polygon has all congruent angles and sides if and only if it is a regular polygon. All right, our last example. So we're going to actually put it all together. If you guys are looking at me right now, I just did like a big old circle all together. Okay, so just visualize me doing that. Sorry, no, that was not funny at all. All right, so what we're going to do is we're going to write the hypothesis, the conclusion. We're then going to write the conditional statement. We're going to write the converse, the inverse, the contrapositive, and then finally the biconditional if one of them exists. So remember, the hypothesis does not include the word if, but it's the statement that comes after the word if. Your conclusion does not include the word then, but it comes after the word then. Your conditional statement is the if-then statement. The converse is when you switch the hypothesis and the conclusion. The inverse is when you negate both hypothesis and conclusion. Contrapositive, contrapositive. Two things you do. You switch the order and you negate both. Our biconditional, okay, will only exist if the converse and inverse are basically true. Okay, if one of them is true, well, typically they're equivalent statements, so if one's true, the other one's true. So if the converse is true or the inverse is true, then therefore you actually can justify writing a biconditional statement. All right? Here we go. 4x plus 9 equals 21 because x equals 3. The hypothesis, x equals 3. The conclusion, that 4x plus 9 equals 21. Now remember, our conditional statement, P implies Q. Okay? So we get, if x equals 3, then 4x plus 9 equals 21. Now the question here is this statement in fact true? Well, you can always plug it in. 4 times 3 plus 9 equals 21. 4 times 3 is 12. 12 plus 9 is 21. Because that's true, then this statement is true. All right, now the converse. Remember the converse, we switch the order, okay, of the hypothesis and our conclusion, okay? We just switch the order. So it would state, if 4x plus 9 equals 21, then x equals 3. Well, what do you think? True or false? That statement would have to also be true. All right? Now let's write the inverse. Remember, for the inverse, we negate the original hypothesis and the original conclusion. That's all you do. You just negate it for the inverse, okay? So when we negate them, we get, if x is not 3, and you demonstrate not 3 by putting a slash through your equal sign, okay? So if x is not 3, or not equal to 3, then 4x plus 9 is not equal to 21. Well, what do you think? Is that statement true or false? Hopefully you're saying that that is true. And lastly here, well, not really lastly, but the contrapositive, which we can for sure 100% write, is, again, 2 parts. You negate both parts, and we switch the location of the hypothesis and the conclusion. So in doing that, we get, if 4x plus 9 is not equal to 21, then x is not equal to 3. Hopefully you are saying, for your truth value, that this statement is actually coincidentally also true. So for your biconditional, check your truth value of your converse and inverse. Notice that both your converse and inverse were both true statements. So if they were both true, then we actually can write a biconditional. So here we go with our final answer. The biconditional of our conditional statement is x equals 3 if and only if 4x plus 9 equals 21. All right, so hopefully you guys are digging this logic. And I'm out. Adios.